Okay, Algebra 2, this is the last video that I will post, and then you are officially graduated from Algebra 2. Chapter 9 is where we are at right now, which is actually trig stuff that we just got done learning a couple chapters ago, I guess, while we've been on break. But starting with trig, number 33 is find the value of sine, cosine, and tangent, okay? When we did sine, cosine, and tangent, we did SOHCAHTOA. Okay, and SOHCAHTOA is like the mnemonic device that you use for trig functions of right triangles. And the thing that I need to figure out here is 30, 24. I don't know this other side right here. So what I need to do first is I need to do the Pythagorean theorem to figure out what this third side is, okay? So Pythagorean theorem is a squared plus b squared equals c squared. And in this triangle, my side C has to be the longest side, which is going to be 30, okay? So let's go ahead and say A is 24, this guy is B that we don't know, and then we're going to solve this triangle here. So in for A, I'm going to put 24 squared plus B squared equals 30 squared, okay? And then we'll solve for B, okay? So 24 squared is 576 plus B squared equals 30 squared. 3 squared is 9, so 30 squared is 900. Okay, and then I'm going to subtract 576. So B squared will be equal to 900 minus 576 is 324. And then to get just B, I take the square root of that. Okay, so I'm going to square root that 324, 18, perfect. B comes out to be 18 exactly. Okay. Now, one more thing that I'm going to do before I do sine, cosine, and tangent of this is 24, 18, and 30. When I put these as fractions, I'm going to be able to reduce all of them. So why don't I just reduce them right now, and then I don't have to reduce 3 times when I do my sine, cosine, and tangent. Okay. So 24, 18, and 30, all of them are divisible by 6, I think. 24 divided by 6 is 4, 18 divided by 6 is 3, and 30 divided by 6 is 5. So this is a 3, 4, 5 right triangle, okay? All right, so now I'm looking at this angle theta, and according to theta, I need to figure out my opposite adjacent hypotenuse side. The hypotenuse is going to be 5, the adjacent side is 4, and the side that's opposite that angle theta is 3. Okay, so now when I write out sine of theta, cosine of theta, and tangent of theta, I can just write those out as fractions. Fraction, fraction, fraction. Okay, for sine, I have opposite over hypotenuse. So opposite is 3, the hypotenuse is 5, so sine will be 3 over 5. Makes it really easy. Cosine is the adjacent over the hypotenuse. So that guy will be adjacent is 4, hypotenuse is 5, so 4 over 5. Should have written these a little bit further apart, that's okay. Tangent is opposite of adjacent. Opposite is 3, adjacent is 4, so 3/4 is what he will be. Okay? All right, moving on to number 34. When we are solving for a piece here, instead of just writing them out, we have to choose which trig function to use, sine, cosine, or tangent, okay? And what we base that on is the angle right here, okay? And the two things that are, the two other pieces of information that we're given are what we're trying to find. X is opposite of 64, and 11 is going to be the adjacent side, right? The hypotenuse side is the one that's over here, and we don't have any information for the hypotenuse side, so I'm going to cross them out, okay? So we want the trig function that involves opposite and adjacent, which is going to be tangent, okay? And so I write out tangent of, and we always put the angle in here, 64 goes inside of here. Okay, so tangent of 64 equals, and I write it as opposite over adjacent, just like I did up here, okay? The opposite side is x, the adjacent side is 11, okay? And then if I want to get x by itself, I would multiply the 11 over to the other side, okay? So x is going to be 11 times tangent of 64, which I'm going to do in my calculator here. 11 tangent of 64. Okay, and that comes out to be 22.6, approximately. Okay, so that's what the length of that opposite side is going to be. Okay, all right, 35 and 36 are going to kind of go together when you have a degree measure and you're trying to write it in radian measure. This is what radian measure looks like, 3 pi over 4. This is what degree measure looks like. Okay, if you are trying to switch between them, you're either going to use pi over 180 or 180 over pi, because 180 degrees is equivalent to what pi is. Okay, so the way that I do this is I start with 75 degrees, okay, and I'm going to put that as a fraction over 1, okay, and when I do this, I'm going to set up like a unit multiplier like I would when I was converting like feet to inches or miles to yards or whatever else, okay, and what I want to do is I want to make sure that this unit of degrees cancels out with degrees on the bottom, okay, so in this case, I'm going to use 180 on the bottom and pi on the top to convert him because I want the degrees to cancel with the degrees, okay? And then I just simplify best I can. So 75 and 180, both of those are divisible by 5, I think. 15, 180 divided by 5. Let's go 75 divided by 15 is 5, and 180 divided by 15 is 12. Yeah. If I divide by 15, 75 divided by 15 is 5. 180 divided by 15 is 12. So this will look like 5 times pi over 12. That's what he will be. 5 pi over 12 is 75 degrees. Okay? All right, 36, same way. We're going to do 3 pi over 4, but in this case, I want the pi's to cancel out. So I'm going to use 180 over pi in this case, and the pi's will cancel with each other because one's on the top, one's on the bottom, right? And then I can reduce the 4 and the 180, okay? 180 divided by 4 is, I think, 45. Let me check that. 180 divided by 4 is 45 degrees, yes. So I have 1 on the bottom, which really doesn't do anything for me. But then I have 3 times 45 on the top. And 3 times 45 is 135. So that's what he will look like. 135 degrees is what 3 pi over 4 is. Okay? All right, 37. Name an angle that is coterminal with 590 degrees. That's a lot of degrees. Okay? If I'm looking at like a standard, coordinate plane, if I start here and I go all the way around, that would give me 360 degrees. Okay, I've basically gone back to where I was before. 590 is going to put me like almost 2 full, so I think it's down over here is where 590 will be. Okay, well basically that's going to be the same as if I would have just gone from like here to here, right? Like I could have gone from here to here instead of flipping around twice to get, that angle right there. So coterminal angles are basically one more rotation of 360 or one less rotation of 360. So we can either add 360 to this or subtract 360. In this case, let's subtract 360 so we get a smaller answer. 590 minus 360 is 230 degrees. So 230 degrees will get me in the exact same spot as 590. There's really no need to like spin around, more than once to get there. 230 degrees will get me there faster. Okay, so 38. Find the exact value of sine of 240 degrees. Okay, so what we're going to do is 240 degrees. Okay, if I look here, starting here, this would be 0 degrees. Okay, if I go from here all the way up to here, that is a value of 90 degrees. Okay. Then if I would go from here all the way over to here, this is 180, okay, degrees. And from here down to here, this is 270 degrees. And then I would get back to 360. So 360 and 0 degrees are coterminal with each other, okay, because they land me in the same spot. Right, so 240 degrees would be somewhere in here, between 180 and 270. So what we do is we find what's called the reference angle, okay? And if 240 degrees is from here all the way around to this bottom part here, okay, and 180 is just from here to here, how far is it just with this little guy, right? So 240 is from here all the way around, 180 is from just here to here. So how do I figure out that guy? What I can do is take 240 and I can subtract 180, okay? 240 minus 180 is 60 degrees. So that's going to be my reference angle here. Okay. And then we had a sheet. This is in section 9.3, I believe. Okay. 9.3 that said this. Okay. If I'm trying to find sine of 30 degrees, it's 1/2. Cosine of 30 degrees, tangent of 30 degrees, blah, blah, blah. I have all of those. But then if I go all the way down here, I have sine of 60 degrees. That's what we're trying to find. Yeah, we're trying to find sine of 60 degrees. And that is the square root of 3 over 2. Okay, so sine of 240 will be the same as sine of 60 degrees. It's the square root of 3 over 2, except there's one more thing. One more thing that goes with that. Okay, here, up here at the top in this little thing, this guy tells me that sine in the third quadrant is going to be negative. Okay, so even though it's the square root of 3 over 2, it's actually going to be a negative square root of 3 over 2. Okay, so I'm going to attach a negative onto the end of there, and that's what he's going to look like. Okay, this one was kind of a confusing problem, unless you're actually in trig class. That might be easier to understand why that is, but yeah, that was kind of a tricky problem. 39 is a nice problem. Find the values of the 6 trig functions of angle theta. So they want 6 trig functions, which is sine of theta, cosine of theta, tangent of theta. That's the first 3. And then the one that goes with sine is cosecant of theta. Secant of theta goes with cosine, and tangent goes with cotangent. Okay, so they want us to find each one of those 6 guys right there. Okay, and it says the point that contains negative 3, 4. Okay, so I'm going to draw where negative 3, 4 lives. Negative 1, 2, 3, up 1, 2, 3, 4. It would be this dot right here. Okay, so what I do is I connect him back to 0, 0, and then I make a triangle out of him. And we never make hourglasses, we always make bow ties, which means we connect him back down this way. Okay, right, like bow ties would be, if he's here, I connect him this way. If he's here, I connect him that way. These are my bow ties. Okay, so since he's in the second quadrant, I make him look like this part of the bow tie right here. Okay, all right, and this guy is negative 3, 4, which means that this length from here to here is negative 3, and this height right here is 4. Okay, if I do the Pythagorean theorem to find out what this guy is, okay, he is actually going to be 5 because he is a perfect right triangle, 3, 4, 5. Okay, so I'm just going to skip that part of the Pythagorean theorem. We'll just know that it is 5. And then angle theta is this angle right here. Okay, so if I'm looking at that angle theta, I'm going to mark my opposite. Which side is opposite? The 4, the 5, or the negative 3? Okay, opposite is going to be 4. Okay, the hypotenuse side is 5, and the adjacent side is negative 3. Okay, so here when I go to do my SOHCAHTOA, 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 I want sine. Sine is opposite over hypotenuse, so the opposite side is 4. The hypotenuse side is 5, so this guy will be 4 over 5. Okay? Now, I'm going to do cosecant at the same time. Cosecant and sine go together, but the only difference is it's just flipped. So if sine is 4/5, cosecant is 5 over 4. Okay? Now, cosine is adjacent over hypotenuse. Adjacent is negative 3. The hypotenuse is 5, so this will be negative 3 over 5. And this guy will be 5 over negative 3. That's what secant will be. Okay, tangent, opposite over adjacent. Opposite is 4. Adjacent is negative 3. And this guy will be negative 3 over 4. Okay, that's what he will look like. All 6 of those trig functions. Okay? All right, now, this is mixed review, so these are the ones that we did at the very, very, very end of our review stuff. The first one, write the equation of a line in slope-intercept form. Let's talk about slope-intercept form for a second. Slope-intercept form is slope, which is m, x, plus the intercept is b, right? This is slope and intercept. And what we need to find is the number that goes in for m and the number that goes in for b. Okay, so we find m first. And we find m, or we find the slope, by doing y2 minus y1 over x2 minus x1. That is rise over run. Okay, the rise up and down values are y's, the run values are x's. Okay, so they give us 2 points, and we can find that by plugging that in for m. Okay, so my second y coordinate is going to be 9. my first y coordinate is 6, okay? My second x coordinate is 3. My first x coordinate is 2, okay? So I find out what my slope is. 9 minus 6 is 3. 3 minus 2 is 1. So my slope is going to be just 3, okay? So I know this number right here is just the number 3. I'm going to write him in, okay? And then I need to solve for b, okay? And the way that I can solve for b is either plugging this guy in for x and y or this one. It doesn't really matter. Both of them are positive numbers. Let's just choose the first one, so 2 and 6, okay? I want to make sure that y is actually the y coordinate. So I want to plug 6 in here, and this guy is 2. So 3 times 2 is 6, and then if I subtract that 6 to the other side, b is actually going to be 6 minus 6, which is 0. Okay, so my equation, if I write them all out, is y equals 3x plus 0, or just y equals 3x. I don't really need to have that plus 0 on the end there, but that's okay. All right, next one. Write the equation of a line that is parallel to this guy. Okay, parallel lines have the same slope. Okay, so if I look at this equation, he's written the slope-intercept form. What is the slope? The slope of this equation is 3 over 2. Okay, so if I want him to have the same slope, he's going to be also y equals 3 over 2x. Okay, but he's going to be plus b now. We don't ever use that 9 in there. Okay, because he's going to have a different b. Okay, and to find out his new b, I plug these guys in, just like I did in the problem above. So negative 2 is going to go in for y. 4 is going to go in for x. Okay, and 3 over 2 times, I'm going to do 4 over 1. Okay, 3 over 2 times 4 over 1. If I reduce that, this 2 and this 4 can cancel to become 1 and 2. So I have 3 times 2 over 1 times 1, which is just going to be 6. 3 times 2 is 6, plus b, plus b. We have 2 equal signs there, plus b. Okay, to get the 6 to the other side, let's subtract them. So b is going to be negative 8. Okay, and then I have to rewrite my equation. Let's write it over here. We'll write it over here. Y equals, my slope was 3 over 2, x minus 8 for b. And there he is fixed. Okay, all right, 42. I can solve this using any method. The two methods that I've dealt with already were substitution and elimination. It doesn't matter which one you use. I like elimination better than I like substitution, so I'm going to go ahead and do that method. But what we're going to do here is to eliminate. Let's see, x's, I could eliminate the x's. Y's might be a little bit easier to eliminate though. Okay, so I have negative 1 and I have negative 3. Okay, so if I focus on this negative 3, the thing that crosses out with negative 3 is a positive 3. So if I want to get this y to be a positive 3, I can multiply him by 3. Really, it would have to be negative 3, right? Negative 3 times negative 1 would give me positive 3, and then that would cancel with y, okay? So I'm going to take that, I'm going to distribute him through, and I'm going to write him right below. Negative 3 times 4 is negative 12x. Negative 3 times negative 1 is positive 3y, and negative 3 times 0 is still going to be 0. Okay, now I can add these two equations together, and we'll see what we get. 6x minus 12x is negative 6x. Okay, the y's canceled out like they're supposed to. And 12 and 0 makes 12. Okay, and then I can just divide by negative 6. So my x is going to be negative 2. Okay, and now I have to plug in again to get a final answer. So if I plug my x in, you can just plug it into the top. It doesn't really matter which one we plug into, the top or the bottom. So I'm going to plug my x into the top equation. 4 times negative 2 minus y equals 0. Okay? 4 and negative 2 makes negative 8. If I add the 8 to the other side, I will have negative y equals 8. Okay, and if I divide by a negative 1, y is going to be negative 8. Okay, so I have my x and my y, and I can write that as an ordered pair of negative 2, negative 8. Okay, and this is a coordinate point. And I always ask you, why do I care about that coordinate point? What does he do for me? These two functions are linear functions. It's where these two lines will cross each other at negative 2, negative 8. Okay? All right, 43 and 44 and 45 are all factoring. Okay? So x squared minus 64. This guy is a difference of squares. Difference of squares, okay? And I know that because I can take the square root of x squared and I can take the square root of 64 and it's minus in between them, okay? So the square root of x squared is x, the square root of 64 is 8. One of them is plus and one of them is minus. And now that I have them factored down, I just set both pieces equal to 0. So if I set x plus 8 equal to 0, that means x actually equals negative 8. And if I set x minus 8 equals 0, x actually equals a positive 8. So those are going to be my two answers, okay? 43, 43, 44, 45, those are all quadratic functions, which are parabolas. And so what I'm finding here, by finding those x's, is finding where they cross. So this guy's going to cross at negative 8 and positive 8, okay? Number 44, they want us to factor this guy down. So this is a trinomial. He is a simple trinomial because there's no number in front of the x. So to do this one, I just say, what do I multiply to get negative 8? But when I add them, give me negative 7. Okay, multiply to get negative 8 would be negative 8 and positive 1. Let's see if that works. Negative 8 times 1 will give me negative 8. Negative 8 plus 1 is negative 7. Yes. So now if I set those both equal to 0, this guy, x will equal positive 8 and x will equal negative 1. And that's going to be these two places where they're going to touch. Okay? Right. 45 is the last factoring one. And this is a complex trinomial, okay, because he has a 2 and, well, kind of. Let's see. This is not really a complex trinomial. Shoot. Since all of them, look at the numbers, 2, 8, and 6, I can divide all of them by 2. Ha! Dang. I almost got tricked. I almost had to do that whole big long thing. Let's do that first. So if I divide everything by 2, this guy will be x squared. 8 divided by 2 is going to be 4x. And this guy will be plus 3 equals 0. Now, he's not a complex trinomial anymore. He is actually a simple trinomial. We've divided by 2 on everything. So, I'm going to break him down. What can I multiply to get 3, but when I add them, give me 4? And that is going to be positive 3 and positive 1. 3 times 1 is 3. 3 plus 1 is 4 equals 0. So my two answers will be, if I set them both equal to 0, x will be equal to negative 3, and x will be equal to negative 1. And that's what both of those are. Okay? So where he's crossing right here, like this parabola, is at negative 3 and negative 1. All right? Last one, 46. We want to take the square root of that. Okay? Now, not all of those pieces have a perfect square root. Okay, so I'm going to do each one of them individually. Square root of x cubed, square root of y to the 9th power. Okay, so let's start with a number first. Number that goes into 24 that I can take the perfect square root of would be 4 and 6, I think. Okay, so the square root of 4 times the square root of 6 will give me the square root of 24. The square root of 4 is actually just 2, and the square root of 6 doesn't come out nicely, so I just leave him as the square root of 6. Okay, now moving on to the x to the 3rd power, do the same thing again. Okay, and I always only ever hang one of them off. Okay, so if I hang one of them off, that means x squared has to go in here. Okay, and then I do the square root of both of them. So the square root of x squared is just going to be x and the square root of x, because he doesn't pop out nicely. Okay, now y to the 9th power, because he's an odd power, I have to do this again. If this was the square root of like y to the 8th power, that would come out nicely. I wouldn't have to do anything, and it would just be y to the 4th, right? You divide by 2, okay? So what I'm going to do, since this is not an odd power, or not an even power, I hang one off. I do y to the 8th here, okay? Square root, okay? And we just said the square root of y to the 8th power was y to the 4th, and the square root of y just stays the square root of y. Okay, now I lump them all back together. So the stuff on the outside was 2, and x, and y to the 4th. And this stuff that's still trapped on the inside would be 6, and x, and y. And this is in the lowest terms possible. Okay? All right, so that is it for semester review. You guys are graduated from Algebra 2. I'm sure I'll have you again next year in a different class, hopefully if you all pass. I wish I could see your beautiful faces in person, but that's just the way that it goes. I will see you when I see you.